Inverse Laplace transforms using partial fractions. Starting with a nice question, determine this expression. We don't have any format in our table of transforms that reflects the expression, so we need to break it down into parts that are usable and match the table. So for this we'll use partial fractions. Focusing on the denominator, we can factorise this to get s minus 2 s plus 1. This will then split up into a over s minus 2 plus b over s plus 1. I won't be delving much into the partial fractions process as this video is about using partial fractions for Laplace. We can see that simplifying this we get our separate expressions, which in this case we can compare to get our a and b values, which we can then substitute back into the expression to get 1 over s minus 2 plus 3 over s plus 1. We can split up this expression into two separate inverse Laplace transforms. Using our table, the left-hand expression highlighted in orange resembles this transform here, and the right-hand expression highlighted in green also resembles this same transform. The left orange part matches the expression exactly, which makes our life easier. However, the right green side has a numerical factor of 3 that's multiplied to it compared to the expression we need. Therefore, we can take a numerical factor of 3 outside of the expression, which overall leaves us with the inverse Laplace of 1 over s minus 2 plus 3 lots of the inverse Laplace of 1 over s plus 1. The orange part has an a value of positive 2, as the f of s value is the negative of the f of t value, and the green part has an a value of negative 1. Substituting this all in, we'll have an answer of e to the 2t plus 3e to the negative t, all multiplied by the unit step function. Try these first 5 questions and see how you get on. Answers will appear in a moment before we move on to trickier content. Now that we've got the key skill covered, let's increase the difficulty. We're now dealing with some algebraic manipulation. We've got this slight beast of a question here. As before, the focus is on the denominator to begin with. We want to start getting it into a form we can use. Notice how we can separate the s from the s squared plus 4s plus 52. So let's do that. Using partial fractions, we'd have the form a over s plus bs plus c over s squared plus 4s plus 52. Multiply the denominators and we'd have this. Grouping the like terms together, we can then compare the values so that we can find a, which is 1/4, then substituting a into 7 equals 4a plus c, we'd calculate that c equals 6, then substituting a into 0 equals a plus b, we'd calculate b to be negative 1/4. Substituting a, b and c into the partial fractions, we'd get this. Not the nicest way of writing it, so we'll ensure we write 1/4 over s to be 1 over 4s. Then for the right expression, we want positive 1s in the numerator, so we'll take out a factor of negative 1/4 to leave us with minus 1/4 lots of s minus 24 over s squared plus 4s plus 52. Tidying this up and inputting the Laplace transforms, we have this. I'll also take out a factor of 1/4 from the left expression, as this will help match the inside of the inverse Laplace to the expression in the table. The left-hand part is ready now, so we'll just need to deal with this right-hand transform. With the part we need to sort, I've changed to yellow. We don't have an f of s expression we can use, so we'll need to sort this out by splitting it up, and for this we're going to use completing the square. We can't use partial fractions for this bit, but I'll explain why in the next video. Changing the denominator into completing the square format, we get this. We use the skill learned in the previous video. Altogether then, for this yellow part, multiplying the negative 1/4 back in, we get this. We then have the whole inverse Laplace transform we can determine using the table. I've split each part into green, orange and pink. Using the table to get the a and b values, the orange part will have a equals minus 2 and b equals root 48. The pink part will have a equals minus 2 and b equals root 48 also. Determining the inverse Laplace expressions now, the green part is very nice as that gives us 1/4, minus the orange part 1/4 multiplied by e to the minus 2t. multiplied by cos of root 48t, minus the pink part, 13 over 8 root 3, multiplied by e to the minus t multiplied by sine of root 48t, all multiplied by the unit step function. Now you could have kept root 48 in the simplified for root 3, in which case it would look like this. Either way, you have your answer. Just to give you some helpful tips before the second set of questions, think about the format you want to get. Focus on the denominator initially, this will give you the direction you need to go in. Be aware of these formats, is it plus b squared or minus b squared? Be wary of repeated linear fractions, this can easily catch people out. Split things up as it may use a range of skills as demonstrated by our last example question. 5 questions for you to try now. There are 2 sets of hints ready also if you need a bit of help in the right direction before the answers are shown. These first set of hints show the parts of the table you'll need for each question. The second set of hints here show you how the partial fractions will look. Here are the answers. I hope you did really well on these. These can get tricky, particularly question 50 there. Part 9 shows you how to know whether to use completing the square or partial fractions. Stay safe and healthy out there, and I'll see you in the next video.